Alright, chapter 11, sequences and series. Let's summarize the whole chapter. Now, what you first have to start off with is we're going to start off with arithmetic sequences and series. And then we're going to get to geometric sequences and series. There's two topics basically in the chapter. Arithmetic series, or sequences, are patterns where you have a common difference. What you notice here is we're minusing 7 each time. And the way we find that minus 7 is we just take this minus this. So, or we could take this and minus this. Basically, negative 7 is a common subtraction, or it's a common number added, each time throughout. Thus, this is called an arithmetic sequence. Where if you go down here, geometric sequence, you'll see here that these numbers are divided each time, are shrinking. And if you look, you take 100 divided by 500, you get 1/5. So these are dividing by 5 each time, where these are minusing by 7 each time. So you first got to spot the difference, knowing the difference between an arithmetic sequence and a geometric sequence. Then what happens is you have rules for each. For arithmetic you have a rule. This rule generates terms in a sequence. Over here for geometric you have a rule as well. You have different rules for each type. And for instance, if I want the rule here, here's the equation, you just got to memorize it. What you do, you first have to have A0, which is the term before the 12, the first term. And so if we're minusing 7 this way, we're adding 7 as we go to the left. So if we add 7 to 12, we get 19. So the term before 12 would be 19. The D is negative 7. That is your rule. And what's useful about this rule is, well, if we plug in 10, say we want the A10, the 10th term, all I'm doing here is I'm plugging 10 in right there. Now, when I plug in 10, I get negative 51. And what does that mean? Well, it means that the 10th term, if you kept the sequence going to 10 numbers, would be negative 51. So what's awesome about the rule, it generates terms, where that really helps, especially when you get to this piece. So that's the rule. One thing I always think about the rule is what I think of it as, well, I'm 19. Well, before I start the sequence, I am subtracting 7 in times. So if I want to say the second term, what I'm doing, I'm starting with 19, I'm subtracting 7 twice, so 19 minus 14 would be the 5, the second term. If I want the third term, I'm taking 19 minusing 7 3 times, and so forth. That's the shortcut or understanding of it. Now, the rule right here for a geometric sequence is very similar, but what you're doing is you're starting with the 0 term, and you're multiplying by r n times. So you're multiplying by r n times. Here you're subtracting 7 n times. So if you look here, first we have to find A0. So if we're dividing by 5 this way, you're multiplying by 5 this way. So if we take 500 and multiply by 5, we get 2,500. That's my A0. And my r is 1/5. So if I want a term, say the 4th term, I plug 4 in right here. And 1/5 to the 4th is kind of big. It's 1 over 625. And then if you take this divided by this, you get 4. So what that's saying is the 4th term is 4, which you can see right here, the 4th term is 4. So what's nice about the rule here is any number you plug in, you can get that term. Say if I want the 30th term, you plug in 30, it's going to be really small, but you can find the 30th term. So the rule creates terms. Okay. Then you have here the series. You have a series formula for arithmetic, and you have 2 series formulas for geometric, because geometric can be finite or infinite series, meaning series of adding numbers forever, or finite means only a certain amount of numbers. So let's go up here. The arithmetic series, well, here's the formula to add up terms for arithmetic sequence. So here's a sequence. If we want to add up those numbers, that becomes a series. And the way we add them up is we just got to find in A1 and an, which is the last term. So what's interesting, if I want to sum the first 10, well, my n is 10, because that's how many terms. 12 is my first. And my last term, well, what's nice is we went right here, we did the last term. So if I plug that last term in, then I compute this, and I get negative 195. Now, what stinks, just so you know, about this formula is you need that last term. Sometimes that last term, like we did over here, you have to go and compute that last term if it's not given. So that is an extra step where this formula is very useful, because sometimes you need this formula to get that last term. All right? Anywho, last term. There we go. That would be the sum of this. If we had 10 terms written out, added them all up, that would be the sum of all of them. Now, if we want to do a geometric series, you have these two formulas. They're very similar. If you look at this one and this one, you could tell this one is simply this piece. So if we just take this piece of the finite, you get the infinite. Anywho, so Sn, so S4. If I'm going to sum the first 4, you just plug in A1, which is 500, R, which is 1/5, and 4, which is the number of terms, divided by 1 minus R. Then if you did all this math, this one's really, really ugly. You would add up to 624. Where if you do the infinite series, meaning you add up the terms forever, meaning you kept this going over and over and over and kept going, basically after a while you're going to end up such a small amount of number, the number's going to be so small you're adding, it's basically becomes 0 almost, which you can then get a sum. Because you're adding such small amounts, you could basically stop adding and your answer ends up being some whole number or fraction, some value. So for this one, you just take A1 over 1 minus R. So A1 over 1 minus R. This becomes 5 over 5, which becomes a 4/5. And when you do this, you get 625. Now, look at this. It's kind of crazy. If you just add the first 4, you get 624. So from the 5th term, forever is only adding 1. Because they're such small numbers you're adding. If you add up those numbers, it's such a small amount, you just basically are adding 1 more to all that extra adding of terms. Now, one more thing you have to realize is for finite and infinite, for infinite series, you can only do an infinite series if your R is a fraction less than 1, meaning a positive or negative fraction less than 1. So absolute value of R less than 1. So let me restate that. Your R value has to be a fraction between 0 and 1, but it could be a negative between -1 and 0. But it has to be that in order to do it, because otherwise, if this was, say, 5 and we're growing by 5, this thing would get so big you couldn't add up an infinite amount of terms. So in order to do an infinite series, the first stipulation has to be that the sequence is shrinking. Okay, so basically if the sequence is shrinking, then you can do an infinite series. You can't even do it if this would be growing. So one more summary. You got to know the difference between arithmetic and geometric. Okay, right here, common difference or common ratio. You then got to be able to make a rule for either of them. And you also got to be able to do the sum of both of them. This one here is a sum formula. Here there's 2 different types of sum formulas. And most people struggle because they cannot remember these formulas. There's too many formulas here and they mix them up. Besides that, it's basically plugging in some simple values. Plugging in your 0 terms, your common difference, your last term, your first term, and different things you're plugging in. So hopefully this helps summarize sequences and series. I'm hoping it helps.